Please. Hello.
Eric.
Hey.
How you doing, man?
Good, great.
It's been a while.
Yeah.
So we have another expert to expert today. What's going on?
Well, we're going to interview Jeffrey Snover today from PowerShell. And, what a sound. And so there's an interesting kind of, bit of trivia here, because I think we met each other kind of, many years ago when PowerShell was still called Monad.
Yep.
And then I thought, ooh, Monad. So I was kind of, something inside me was tickled. So I kind of, sent him an email, and it turned out that it was PowerShell. So why was PowerShell called Monad before?
Yeah, so it basically came from Leibniz's modenology. So he believed that the world was composed of these fundamental units called monads, and that monads were fundamental units of consciousness, and that would then decide sometimes to manifest themselves as matter, and then would sometimes decide to aggregate with other matter to solve problems, to implement purposes, and then would disaggregate. And so in Leibniz's view of the world, monads were all about composition. And the whole world was all about composition. And that's what PowerShell is. It's all about composition. You have really small things that do a single thing, and then they compose with other things to solve really hard problems.
Isn't that fascinating? Because that's exactly what in functional programming, what people are using monads for. So it's kind of interesting that and that's also where the word monad there comes from.
Right.
But now there's an interesting kind of difference between composition in PowerShell and composition in, say, a pure functional language that use monads, where there they kind of encapsulate also effects.
Yes.
So, so how are effects dealt with in PowerShell?
They're not. I mean, they're not modeled in that world, right? So in this regard, they're more like an imperative programming. So it's just a functional interface, and I mean that is to say, it's a non-functional interface. Let's say it's an interface. Yeah, it's an imperative interface, and then we stitch them together, and they could they cannot have side effects, or they can have side effects, and the runtime is pretty silent on that point.
But there's an interesting thing that I think I would really like to dig out, is the way that in PowerShell kind of units are composed.
Yeah.
Because they're not kind of just like composed. There's also like how do they interact, and kind of how does the kind of the demands flow in a pipeline of.
Sure, that's actually the magic.
Because yes, that's a lot of magic where.
That is the magic.
Yep.
Hope none of this was.
Are you turning into a manager where you can always see that when the whiteboard doesn't erase?
No, it's that whiteboard that I use.
You want to use this one?
No, it's okay.
All right.
Well, yeah.
Okay, let's do it.
Yeah.
Not very. There we go.
See, this one, that's a work.
That's
an architect's whiteboard. Okay, so if you type, when a lot of people look at PowerShell, right, to see the prompt,
Is the
and a
right
command
color?
like this.
That's not the best color for the camera.
Hey.
Here, black will work great.
Perfect.
How about black?
Black works for me. So when people see PowerShell, they see things that look like this: A pipe to B, pipe to C, pipe to D, and it looks like a traditional command line interface, right? Pipelines, and so by the way, a lot of most successful functional language in the world is command line shells,
yes,
the
exactly.
pipeline. But in fact, that's not in Unix. What this is this is a process, and the output of this process gets piped to the input of this process, and so you have 4 separate processes with data flowing between them. And that's not at all what happens in PowerShell. What happens in PowerShell is that these are 4 tokens, and these tokens then get mapped to .NET objects. And so what we do is we find the A commandlet object, and we find the B commandlet object, the C commandlet object, and the D commandlet object. And these are all .NET instances of .NET classes that reside in a single class. Okay? Now what we do is we reflect against these .NET classes to extract the grammar. And that's what drives a common parser. But then what we do is, in fact, this is all running in an object flow engine. Okay? So, object flow engine, what's that? Well, it's like a data flow engine, right? Except we have objects instead of data. So specifically what happens is we pass control to this first thing. It runs until it emits data. And that data is then handed to the PowerShell engine. And what PowerShell does is it takes a look at the downstream guy and takes a look at its data requirements. And we'll take a look at what data we have and what data this guy needs, and we'll do whatever casting, coercion, manipulation required to meet one of the data contracts. It then runs, and we just do this again. And so the point is that we have all this great data manipulation and binding that goes on underneath the covers. And this is what I like to say is it's like programming with hand grenades instead of sniper rifles, right? Because you just sort of say, it's sort of got to work. Now let me be clear about that. Like this guy here, like say this was something that then did something like stop process.
Okay.
And so what could you do to stop process? Well, one of these can say, well, I require a system.diagnostics.process object. Okay, and that's what I call an is-a binding, that the object is a system.diagnostic.process. Now the point of that is, well, the data requirements of this define how many people can talk to it. Okay, so when its data requirement is something as specific as system.diagnostic.process, it can only talk to things that generate that, and there aren't very many of those, like get process. But it also has one. See, I did two dots here. This one can say, hey, I require something with a property whose name is ID, and that's an int. Or another one that has a property called name, and that's a string. Okay, so now there are three data bindings here. System.diagnostic.process, that's an is-a. These are has-a. And what that means is it will go and take any object, and if it has a property called name, which is a string, it will bind to it. This commandlet then takes the name and binds to the system.diagnostic.process to run with it. So by doing this is-a versus has-a binding, all of a sudden the things that can pipe to it just explode, right? These can be queries to a SQL database. They can be import CSV. It can be pipe some XML. I mean, it just can be anything. So that's the explosion, and that's why it's so productive. As again, you know, you're programming with hand grenades. Just I sort of want something like this, and make it so.
Nice.
Very
nice.
I have a couple of more questions about this. So first of all, the kind of the object flow engine. That's kind of it's like push based, right? So it's not that the objects downstream kind of pull upstream, but the ones there, they push their data kind of further down the pipe. Is that correct?
Yeah, it's the opposite of link.
It's the opposite of IEnumerable. Yeah. Yes. Yeah. So then the question is like how when you do that, how do you know that that this next thing is kind of ready to receive? Kind of how do you throttle? Because when you're doing demand driven with move next, it's the kind of consumer that kind of says, oh, I need the next one. But here, how do you kind of prevent like B from being flooded with data from A?
Because we control everything. Our hands are all over it. So what literally happens, right? I showed this as he emits one piece of data and he runs this.
Yep.
Now the other thing is that these are all. If you were to set a breakpoint here and take a look at the stack, what you'd see is D with this on the stack and then C. So it's all running on the same stack. Right? It's all running within one thread context. And the reason for that is, as you know, .NET allows the caller to implement the concurrency control protocol. Well, in this world, our caller is the guy at the command line. There's no way in heck, 60% of the programmers we hire can't get threading right, much less I'm going to hand it to admins and users, and they're never going to get threading right. They're just never. So we've implemented a model where you don't have that. You all execute on a single thread. Now that said, we do have some buffering in here to have better cache coherency, right? So instead of one and then one, you can put in a buffer, and you can control the buffer. The benefit of this model is that each one of these commands has their own parameters, right? So D might take a minus parameter 1 and minus parameter 2, right? But there's this idea of a ubiquitous parameter, right? And so that is to say every variable, so every command supports output variable, error action, output buffer, and these are all implemented by the engine themselves. And so one of those is the buffering, the degree of buffering.
Okay.
How many objects I'll get in buffer before I call the downstream element.
And so when A calls B or pushes the data to B, is A kind of terminated and then is run all the way from the beginning, or do you kind of maintain state kind of
Yep.
while you're pushing the value to B?
We maintain state. What we do is we set up, when you do this, we take a look at this and we produce this object graph. And then what we do is, before we do any work, we call each one of the elements in the object graph and we say begin processing. Okay? And so that might be something that says, hey, this guy might want to connect to a database, and when we're done, then unconnect. So we can do that during the begin processing phase. Then we call this, he emits data, and then for each one of the data elements, we call the downstream process, we hand it to it, and call process record, and we do that until he's done, and we then finish,
Yep.
and then we call each one of them's end processing. And at any given point, if somebody's on the side and hits Control-C, we'll go through and call each one of these from a separate thread saying stop processing.
Okay.
So it was designed from the very get-go to be stream-oriented.
Okay, that's nice. And the other question I had, so is like you say, there's kind of several of these kind of little interfaces or bubbles. So how do you determine which entry you call? I mean, maybe there's like there's some overlap or
Yeah.
yeah.
So that's the magic. So that's actually one of the most complicated parts of the system. But what we do is we take a look at the data that we have. We first evaluate the ISA bindings.
Okay.
That's the strongest binding. Then what we do is you can specify a default parameter set. What we call these are parameter sets. And we just evaluate the strength of the different bindings of the object we have against the parameter set, and then pick the strongest bound.
Okay, so that sounds like similar to what C# and VB do for overload resolution, where there's multiple possible calls and you kind of somehow find the best match or the one that you say the strongest match, I guess.
Yeah, exactly. This is what I call the face of God phenomena, right? I mean, so why is it that you're doing a bunch of work and it looks very similar to the stuff I'm doing, and these guys are doing stuff? Boy, doesn't Link look like a bunch of this? And the answer is, yeah, there's a face of God out there. There's some things that don't work, and there's some things that do. And we might approach it from different perspectives, but basically there's some reality and some power there, and some common ways of doing it, and that's why so much of this looks similar.
Yeah. Good. So another question. I really kind of I'm fascinated by this kind of this engine. So but you said that it all run in a single thread.
Yeah.
But I could imagine that given like all this stuff with many core and so on, that there's kind of obviously a lot of potential for doing things in parallel there in this pipeline, and then have like a data flow engine where you do as much as you can in parallel. Did you look at that or?
Yep. So the trick is, when will we know whether or not you can do that? And therein lies the trick. And currently we've said we're not smart enough. What we do is we do concurrency at the top level. So let me explain that. So let me just fill out this picture a bit. So in fact what happens is, this being the engine, there is a host process. And this is what took the A, pipe to B, pipe to C, and handed it. And what this host process does is it connects to one of these engines, and then takes this and passes it to run. Okay? Now, this host process can connect to multiple of these, right? So it can connect to multiple engines. We call them run spaces, and you create a session to a run space. So you can have multiple sessions within one process. Or in version 2 now, you can create these sessions to remote machines.
Okay,
so it's very much like the ADO model. You say, oh, I'm a host. I'd like to connect to a PowerShell engine, and it's here, or it's there with a different set of credentials, or here's how I'd like to connect to it, and I'd like to connect to 1, 2, a dozen, etc. And so right now, that's the way we leverage parallelism. When we get smart and are able to take a look at this, because here's the thing, right? Now you think about it, right? The tie-in with SQL. What does SQL do? When you type some SQL query, what it does is it goes and takes that and says, you've expressed your intention. and I'm going to take your intention, and I'm going to figure out the most optimal way to implement it. And it does this query plan to execute it. At some point, you can see that we'll be able to do the same thing, but obviously that's not the higher order bit for version 1 or version 2. But we certainly have the mechanism to do that. And then we just need to be clever about knowing when we can do it and when we can't.
And so when the engine is like a remote, how do you send the kind of program across, or do you assume that it's already available on the other side, or do you serialize that code and send it across?
Yeah, exactly. We serialize the code and send it across, right? So you take this and you code it. And we've got a couple different ways to do that. You can either send it across as a string to go and execute, or you can send it across as a data structure. And the difference is important because in like a services environment, you don't necessarily want to be exploiting the parser on the back end, right? Because that can consume resources. So there, when you connect, the remote connection can say, I only take data structures, and then we'll pre-parse it here. And then when you send the results back, right, you issue a request and you get the results back, when this line, let's see, so this line, when it's in process, you can get the object back, but when this is a network, little cloud, small network, little cloud. What we do is we take the objects and we serialize them, and then what you get back here is a data structure, an object graph of the data structure. So let's be clear about this. So imagine that I'm here and I want to talk to, say, Exchange 12. Well, one choice would be, well, geez, I'd like to get Exchange 12 objects back. But if you think about it, that doesn't really make sense. I mean, it sounds good, but now what happens if I talk to Exchange 12 and then I want to talk to Exchange 14, right? Well, because if an object means code, right? So if I wanted Exchange 12 objects back, that means I had to put Exchange 12 on this machine. Well, it's my laptop. I put Exchange 12 on it, and then I want to talk to Exchange 14, so I put Exchange 12 and Exchange 14. Just bankrupt idea. Will never work ever, ever, ever. Plus, honestly, most groups don't take serialization as seriously as we do in the management space, and so we took the traditional management solution to this, right? So management solution. Today you can go out and buy an S&P router, and software that was shipped a decade ago will manage that. So too, you can buy S&P software today and it can go back and manage stuff from a decade ago. Why? Because we figured this stuff out a long time ago. So what you do is you take the object and you turn it into an object graph of types that are going to be constant across space and time, right? I mean, I just take my badge out and I say, if these data types don't work in 20 years, you can fire me, right? Because strings aren't going to change in 20 years. Integers might change, but int 16s won't. So it's things like that.
But even with strings, what about Unicode and all that good stuff? So
we're all Unicode.
Okay. But
as long as we don't introduce.
But 20 years ago it was all ASCII, so I mean even strings kind of change. So how do you
Well, I might have to retire then.
Okay, well yes, this is right.
You're close, right?
Yeah, thanks.
Well, you got a lot of patents over there.
Yeah, a couple. Not as many as Erik.
So I have a question back to Erik's first excellent question about why you named this monad.
Yeah.
And I recently, of course, had a great conversation with Brian Beckman. It was a little heavy on the theory side, but it was all about the state monad. So when you were talking about state, I was thinking about, did you guys implement any monads in your implementation? Are you using monads? So in your data, are you using a monadic abstract data type?
No.
You're not?
Nope.
Okay.
But I would disagree with that because I think I think actually that pipeline that he showed is like where each little kind of thing, that's a monad, and the composition, the way it's composed via the engine, that is like some particular monad. It's not the state monad, it's the PowerShell monad. Because I don't know if you kind of remember or you have seen any of the kind of functional programming monads.
Yeah.
The idea there is that you have some piece of functionality that has some additional wires. So
Right.
for example, like the state monad is one example where you want to pass around state. So one function manipulates the state, you pass it around to the next one. And then the monad tells you how to wire those components up, and that's kind of exactly what you guys are doing here. You have these independent units, and they have to communicate via this this ether, which is the monad.
The ambient monad.
So I think
objects.
Yeah, so you're kind of really close to the original roots. Maybe without kind of noticing, but it's really kind of
It's great. I got a field promotion. I like
yes,
that.
exactly.
Nice job,
Yeah.
Cool.
Yeah. So another question is, I mean, I like to kind of drill down. So
Sure.
Charles, you should say when we have to kind of go up. But
I think we should go down further.
okay, good. So when you write that little kind of fragment above, like A pipe, B pipe, C,
Yeah.
and then you said, and now we create .NET objects, these commandlets. But there, I think you were kind of waving your hands a little bit. How
Yep.
do you know that when there's A there, that you have to create some commandlet? How do you bind those, names to the actual commandlets?
Yeah, so we've got a token resolution. I did gloss over that. So it's a token resolution. We get the token and we first say, is it an alias? And we'll expand it if it is. Then we look for it in a function. And then we look for it in the commandlet table. So how do I populate the commandlet table? So here we've got a version 1 and version 2 answer, and then a future answer, right? So in version 1 and version 2, what we do is we have these things called snap-ins. It's like an MMC snap-in. You say, I'd like to import the snap-in, and then all the commandlets, it's a DLL,
Okay.
and then we reflect against that DLL to extract all the commandlets and populate the table. That's the answer.
And the table is a mapping from names to, or tokens to the actual
implementing type.
Okay.
Yeah.
Okay.
And then if
Yep.
we don't find it there, then we look in the path, because at the end of the day we're a shell.
Okay.
Right. So you could have said one of those things could have been Notepad or ipconfig or some existing Win32 executable, and we'll bind to that too. And in that case, what happens is the .NET class is in fact what we call a native command processor. And we configure it to say run ipconfig, but it has the begin, process record, end process as well.
Okay, and so what happens if you register or put two commandlets with the same name in the table?
Yeah, so it's the traditional model. You have short names, get process, and you have the long name. Now the traditional long name for a commandlet has been the path, and ours is a modified path. It's the name of the snap-in / get process.
Okay.
Yeah, traditional stuff.
Yeah, so but that's really kind of one way to look at that. In modern terms, you're doing dependency injection. Because you're kind of you have some kind of indirection of going from names to objects, where people trying all kind of fancy ways to kind of to do that.
Exactly.
Yeah.
And the better way to do it is to have kind of a ubiquitous registry for these things. But we didn't get that in this time frame. But you missed the fun spot. Okay, so here's the key.
Okay.
Here's where there's so much fun in this architecture. So what did I say? I said I've got a .NET class and I reflect against that .NET class to extract the grammar. So how does that work? And the answer is the .NET class has a set of properties. I take a look at each one of the properties and I say, do you have the attribute parameter? And then the parameter can have things like validation constraints, can have one, can have multiple, is there a regular expression, blah, 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 blah. But extract all that and it's a grammar. And then that grammar is handed to this host, and that then drives a common command line syntax. Now, a couple things. The original syntax for PowerShell was in fact VMS's DCL. Because I love VMS DCL. That was great stuff. It had problems, but it had this thing they did very well. And at some point I said, you know what? We want to make this open. We in fact submitted this technology to the DMTF, said they were trying to standardize a console for hardware. We said, no, that's not the game. We want to standardize a shell for everything. Shell for the hardware, you're in BIOS, raw machine, you're in BIOS, what should you be able to do? We were saying it should be PowerShell. And then the same thing should be Windows, and the same thing should be for Unix. So literally a cross-platform shell for everything.
Okay.
And I looked at that and I said, there's no way they're going to buy into a VMS DCL for that. So we said, hey, we're going to switch and make it more Unix friendly. So we switched to dashes, spaces between parameter and value, etc. And that took us a couple lines of code. Why? Because there's a single common parser. Okay, now it gets better. So now what we do is we say, well, so the command line is just reflecting off a parse across a grammar. In version 2, we make that grammar programmable. Okay, so what that means is people hosting web services in the sky, they'll say, hey, Charles, you're coming in. I take your live ID. By the way, now in PowerShell version 2, it can be an IIS hosted application.
Nice.
Okay, so you come in, says, oh, I take your live ID, I look you up in a database, and I say, 1, you're not getting all these commands. You're only going to get 10. And I grab something, and I'll say, hey, it has 100 parameters. I'm going to remove some of them. You don't get them all. And this one, I'm going to put some constraints on it. And then I hand that to the host. And all of a sudden you get a very different set of commands than you, because you're giving me $5 a month. So you come in and I'll say, oh, you get more parameters, and I'm going to take away a couple because they're only for the guys who are running the data center, and I'm not going to put these constraints on, and now you have different projections. Okay? But wait, it gets better. Because now you're there and you're sitting at your desktop and you've got a command that says invoke command, and it's that endpoint up in the cloud, and then you give it a lambda, squiggle brackets, anything you want, end squiggle bracket, right? And then that goes up into the cloud and runs. But what you do is you say, hey, when I connect up to the cloud, we go and the connection command goes up to the cloud and extracts the grammar. So here, you took the grammar, this guy manipulated it, produced another grammar, that then gets pulled across the wire, and we made a local proxy. So now, on the machine, you say help, you see those commands. It's like, wait, I connected. Before I connected, I had 100 commands. Now I connected, I have 200 commands. Where do those commands come from? Well, they're proxies. I say help, I get help for those commands. You get different help than you do. Okay? And then I type the command, tab, completion, etc. It just takes the request, sends it up to the cloud, executes in the cloud, you get the objects back. We pull down the formatting information, so the object gets formatted. You get objects. You're not getting text. You can manipulate it all you want, and then when you're done, they get formatted properly because it's all metadata driven. So it's wild, and it's completely safe. We've gone through and made sure that there's no you can do this. You can connect to Dr. Evil's web service, and you're perfectly fine. We ensure that no code's going to pass through.
Interesting.
But now if you're going over the wire, right, and over the network, so how do you deal with like latency and errors? Because that's kind of different than doing this, executing these things locally. Or do you make that distinction, or do you?
No, we always assume things are going to fail. I mean, that's
it. Okay, so you kind of make the kind of, in memory case the same as the...
Yeah, exactly. Okay. We're pessimists. That's my joke about PowerShell versus other language guys, right? Other language guys live in a wonderful world, a world where when things, they just say what should happen and it works. And then they say, oh, we ought to probably have a try-catch in there. We don't think that way at all. We think things fail all the time. They do. They fail all the time, right? Because you say, oh, I'd like to do this on 1,000 nodes. How many times does that work for all of them, right? About 0. So for us, Tolstoy once said, like the poor, they're with us always. Errors, like the poor, they're with us always. So, the protocol's built that way, the semantics are built that way. When you say, I'd like to A pipe to B, and you have this pipelining where A generates 1,000 things, and then B, maybe fails for 50 of them. Well, the question is which 50? And so what we do is we have 2 pipes. One pipe is all the stuff that worked, and another pipe is all the stuff that didn't work. And so you can collect that. Why didn't it work? What did I try and do, etc., and use it as an input to another script or a mediation script.
Okay, so how would that kind of in that picture, right? So so you have there, the picture where the data flows from A. So does the kind of failed data also flow to B, or does it flow on a completely separate channel, and do I build another pipeline to deal with the error cases?
Yeah, it flows on a different channel. In fact, the way this had originally been spec'd out and designed was that what I've shown you here is a DAG, right? But in fact, my idea was that it just did graphs, and that you could have cycles, right? Well, why would you want that? And the answer is, and so basically any individual element has n streams, right? And so there's output, which I drew down here. There's error. There's warning. There's verbose. There's debug. Right? So there's a number of different name streams, and the original design had it so that these could all have their own graphs.
Oh, you could wire them up, kind of, yes, okay.
Yeah, exactly.
So what happened to that? That sounds like quite elegant.
Oh, indeed, and because then you could do like monitoring.
Yeah.
Like I just throw this thing and it monitors it and has a complex state graph. And the answer was, we looked at that and said, how are people going to type that in at the command line? So we said, we'll hold off on that. So we didn't implement that. But what happens is, this is a pipeline, and then these other streams, they get shunted off to basically a bus, a common bus, with tagged messages. This common bus, here's the stream that I came from, and here's the message. And then I mentioned to you that because these are hosted, the engine can have common parameters. One of the common parameters is error action. And that is to say, when you emit an error, we ask you to draw the distinction between something that just failed and something that failed in a way that nothing else is going to work. Okay? And things that failed in a way that don't work, you throw a terminating error and you terminate the pipeline. But something that just failed, you send on the error pipeline, error, and anything that goes on the error pipeline, we decide what to do based upon the error action. And the error action can be continue, in which case we just emit the message and continue. It could be silently continue, which is to say we suppress it and continue. It could be stop, which is transform an error into a terminating error. Or it could be inquire. And inquire, we stop, ask the user, hey, here's what happened, what do you want us to do? And they can stop or continue. The other thing is there's error variable. And so you can say, hey, I'd like to go, and anything that goes on this channel, I'd like to put into this thing. And the thing if I don't get it in version 2, I'm going to get it in version 3, because I finally figured out the syntax. And the answer is, I should be able to say, well, let's say error action, and have a lambda.
Yep.
Right? And so with a lambda, then I just take the error action, pipe it into this, and perform things. And now all of a sudden I figured out the syntax to do at least some tree-structured graphs in a comprehensible way. Cycles, still not, but I can do graphs, some pretty rich stuff this way. So it's pretty psychotically powerful. That's the thing I think people are surprised on, because some people... They hear shell and they're like, oh yeah, shell.
Exactly.
It's like, no, got to stop thinking. This is not your grandfather's shell, right? This is a very rich language. Indeed, you can treat it like a simple shell, A pipe to B, or you can treat it as a very sophisticated language and runtime engine.
And so what about transactions? Because now, I would expect that, if you have like failure, I would want to kind of, say, A and B kind of, go in a transaction, and if anything fails, I want to kind of, undo, or do you have a notion of...
Okay. I'm in. Now, thanks to Erik in version 2, I'll put transactions in.
Okay, well, we should sign this in blood.
in fact, I knew you were going to ask for it, so I shipped it. It's in the CTP.
Good.
So now you can say, and to my knowledge, this is the first shell that supports transactions. And so what you can say is, I'd like to start a transaction, and then the commandlet has to support transactions.
Yes,
some do and some don't, but they declare that they do. And then when you do that work, you can say, I'd like to do this work using a transaction, and all the registry operations in version 2 support transaction, and then you can say commit it or undo it. Stop the transaction. So yeah, I'm so excited about this, because it's my view that software works when it works and fails when it fails. Right? Yep. You're going to do 10 things and you do all 10, happy. If you do 9, you're screwed. You do 8, anything other than 0 or 10, you tend to be in trouble. And so transactions are natural. Now it's going to take us a long time to get there, but we will get there. And if you think about it, a lot of systems used to have transaction-oriented stuff, right? Like Unix. Unix at some level is transaction-oriented. And what do I mean by that? Well, you edit etc hosts. Right? You edit it, you bring up a file, and you change, and you change, and you change, and you change. And if you don't hit save, you undo it all. And if you hit save, the file gets saved, and all those things are saved. Yeah. And so it's transactional. And so it's very nice semantics. Now there, it's only one file, etc. We can be richer and more sophisticated, but that idea of like do it all or do nothing is critical.
And what interface do these commandlets have to implement to be transactional? Is that system.transactions?
No, we have our own I support transaction. And the way that works is then you support that and you define a set of properties. And what we'll do is we then add this -use transaction. We add that to your commandlet. And then we'll manage the transaction. So we use the system transaction stuff, right? We're not doing that work, but we'll just manage it and make it available to the commandlet.
Okay, and then do the commandlets then have like a compensating action, or do they have to kind of? So what is the exact interface? I'm curious.
Yeah, so that's part of the system transaction. It does that. It'll call it back.
And so, is there any relationship with the kind of the software transactional memory that they just shipped?
No.
Okay. Oops. Wait a second here.
That's fine. No,
I think that they didn't ship. They shipped it on an internal side, so probably you have to kind of cut it here.
Maybe not.
Maybe not.
But let's just continue.
Yes,
man.
okay.
Everybody knows about software transactional memory.
Okay, good.
It's been on Channel 9. I was on Channel 9 about 2.5 years ago.
Okay, good.
So it's not like it's anything new.
Because that
you didn't say anything about who shipped what. So I'm not making any edits.
Okay.
He's putting his badge on the table.
Okay,
baby.
good.
I am, man, because I don't want to do that.
Okay. Because the interesting thing would be that if the commandlets kind of were kind of implicitly transactional, then you don't have to kind of implement any interface yourself, right? So they would kind of then you would get the whole transactional thing by itself.
Yep.
Because I guess in general it's quite hard to implement that I support transactions interface.
Yep. Yeah, right. It's not going to be easy.
Yes, exactly.
At all.
Yeah. And because that's I think if you don't have transactions, having all this error stuff, because you never know how far in the pipeline something went wrong, I guess, right? Because you put it all on this kind of error channel.
Oh no, we know I'm telling you, here's my philosophy.
Okay.
When something goes wrong in general, and especially with errors, we optimize for the person, not the CPU. Who gives a damn about the CPU? Right? We care about the person, right? And so we care about them being able to say, hey, my hair's on fire, I got to solve this problem really, really quickly, right? And so that's why we do a bunch of the stuff we do. Well, the stuff we do is expensive, right? Oh, it could be this, could be this, could be this, all dynamic, right? I didn't talk about the adaptive type system, but the adaptive type system makes it even easier to do this programming with hand grenades, where you say, well, I talked to you something that it said, oh, well, you can bind by name.
Yeah.
Well, you might have an object that emits process name instead of name. So what do? And the answer is, no problem. Just go back to that team and have them re-implement it using it name instead of process name, then wait 2 years for them to do it or not do it, and then when they do, then just throw everything you have away and install the new stuff, and then you're problem solved.
Yeah, sounds good.
That's what I call a low-class solution. Right, and so we have this adaptive type system. Adaptive type system says, hey, those guys who produce that code, you don't have to believe them, right? I mean, they're important guys, but they're only one part of the chain. So what you can do is you can go and say, oh, they said process name, that screws up all this binding, they should have said name. Whenever you see one of their objects, map the word name to process name. And in PowerShell, it now has two properties, process name and name, and the binding all just works.
And so where do you plug that binding in? Is that per kind of engine, or is it global?
Yeah, it's per engine. So basically we have these type extension files, metadata files. We have metadata files for formatting and metadata files for type extension. And then and you can extend the instance of a type or the type, an instance or the type itself.
Okay, and
but where I was going was that we spend a lot of energy trying to make sure that the human is productive, and no more so than when an error happens. When an error happens, you want to collect all the stuff that's necessary for them to figure out what went wrong, why did it go wrong, etc. I don't mind spending a couple extra K to tell you, which element of the pipeline, which object was I on, etc. That's all a really good investment. Anybody who tries to be efficient during error phases, they have a different worldview than I. Is that political?
No, that's good.
That's very
that's
kind, gentle.
Yeah. So just to kind of get back to this binding, right? So is that done with a commandlet too, or so where while you're binding, you're kind of calling out, or how do I specify this? When I say I want to change, whatever, get name to name or something like.
Yeah. Okay. So what happens is when the object gets emitted, basically. we call these, you call commandlets, and they emit objects.
Yeah.
And then they've either given us a PowerShell object, or we convert it to a PowerShell object. When we convert it to a PowerShell object, that's when we bring in the extension mechanism.
Yes, but is that extension again done as a commandlet?
No.
Because that would be nice if it would be all kind of self-referential.
Yeah? No, I didn't get.
So I just give a pipeline that kind of does the binding.
Yeah, it's automatic.
Okay.
Exactly. Now there is a commandlet to extend an instance of an object,
Okay.
but if you want to extend the type, it's a set of XML files. I'd agree. If you're saying,
Yes.
boy, there ought to be a command to do that.
Exactly, that's what I'm saying. Yeah.
Boy, I'd love you to make me do that.
Yes. So why don't we why don't you do that in the next version?
Excellent. Oh, that next version, sure, but I want this version.
Okay.
If you can file a bug. We're now at the phase, we've just entered escrow. And in escrow, that means, beta escrow, that means that if I come up with a good idea, I can't implement it. I have to have a customer come up with a good idea. And you look like a customer to me, so if you just fill out the right form, I can do that.
Okay, I'll file a bug for that.
So what the real answer is that if you don't get that in version 2, Erik's to blame.
Yeah, because I really like this idea of kind of if you're fully compositional, that
Exactly.
you can express everything also kind of in itself, that it's composable by itself.
Yep.
And I see that kind of in a lot of places, so I would have expected it here too. So that's definitely a bug.
Yeah, no, I agree it is.
Yeah.
Well, you know what it is? It's really just, if you take a look at what we've done, right? So in version 1, boy, there's a ton of innovation in there. And version 2, in fact, there's at least as much, because we're able to take advantage of the architecture we did in version 1 and just put together 1,000 lines of code to pull it together. And there's just an amazing amount of stuff in version 2. Anyway, there's always that, like, oh, what about this, and what about this, what about that? In other words, we've really covered a lot of territory.
Yeah.
Yeah.
And so how do you debug the programs like this? I mean, do I put a breakpoint kind of on the pipes, or I mean,
Yeah.
how does that work?
Yeah, so it's psychotic. So in version 2, it's crazy wonderful. It really is. So in version 2 now, you can set breakpoints, right? You can set breakpoints on a particular file, particular line number. You can put it on a line, or file, line number, column number.
Okay.
You can say, oh, in this file, I'd like to set a breakpoint on any command that matches this regular expression.
Okay.
You can say, I'd like to set a breakpoint on these variables, and I'd like to set them when they're read, or when they're written, or whether they're read or written.
Okay.
Then you can go and you can say, okay, I hit a breakpoint. What happens? And the answer is, you can break. If you specify nothing, you break, and then you're in interactive mode, and you can examine things, do whatever you want, change the environment, continue, you take a look at your call stack. But when you set the breakpoint, you can also specify an action, and the action is a lambda.
Okay. Which can be itself then be a script.
Exactly.
Yeah.
Exactly. And so then you can do anything you want, and then in that script, if you say continue, we continue, and if the answer is break, you can set break. So you can say, geez, what? I ran this script and X is 17. How can X be 17? It's supposed to be colors, right, or whatever. And so you say, well, I'm going to set a breakpoint on X whenever anybody writes it, and if it's not 17, just continue, and when it is 17, break. And you'll know exactly when. I mean, it's just crazy.
Yeah,
It's
that's
wonderful.
cool. Yeah, that's really cool.
And then also in version 2, we have the integrated scripting environment. So the integrated scripting environment is a graphical scripting environment. So you can go in, see your script and syntax highlighted editor, set a breakpoint, you have line editing, and click, 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 single step through, shows you where you are.
Good.
Yeah.
So and do you also have Visual Studio integration or?
No and yes. No, there's not Visual Studio proper. We've in fact had an intern come in and do some of that, and that looks interesting. And we might do something about that in the future. But in fact, our integrated scripting environment is based upon a control that is the next generation Visual Studio control.
Okay.
So it's a new WPF control. We've got an early drop of it, and so you're going to see convergence in that area. Might take a while, but
okay, because I think it would also be nice if I could just like having a C# or a VB project that I could kind of just use PowerShell as as a normal programming language
Exactly
Yeah.
correct. Yeah, right now we're kind of focused in on the administrators. You know, this is, I don't know if you got the big news, but so now in Windows 7, PowerShell is going to install in all
I
versions
saw
of
that
Windows.
at PDC, yeah.
Yeah,
It's like-
on by default.
yeah.
Is that crazy? So, roll
So
on
let's talk about that real briefly. I mean,
Yeah.
what do you mean on by default? So in Windows 7, the client, like
Yeah.
the PDC drop,
Yeah.
there is PowerShell. But it's not just that PowerShell is there. Windows actually uses PowerShell. Can you talk about
Exactly.
how Windows is using PowerShell?
Yeah, so this is how we're in on by default, is that the Windows diagnostics is all PowerShell based.
Uh-huh.
So these guys, they're like, oh, you know, diagnostics are critical, and they went off on this design. They had this, you know, XML based thing to do diagnostics, and they sat back and they looked at that thing and they said, no, what we got to do is get the industry to produce a couple 100,000 of these. And they looked at it and said, how are we going to do that? And then they looked at the PowerShell momentum, saw, you know, 30 books, saw the incredible adoption, and said, well, that looks pretty reasonable. And they redid their design, and it's all PowerShell based. It's 100% PowerShell based. And that's why every version of Windows 7 on the client, it's there, and why you can't uninstall it.
Excellent.
Yeah.
And so no more batch files now? It's like, is it?
Well, they'll still be there. They're like some disease you die with but not of. You know, you can't get rid of that stuff. But yeah, I think you'll see fewer and fewer usages of them. Yeah, I mean, because I don't know if you've seen, like, VB script as well, right?
Yeah.
We've had people who took, you know, a 750-line VB script and turned it into a 15-line VB script. Or this one guy came up to me at PDC and he says, you know, I heard your story about that. He says, I took a 481-line VB script and turned it into a single line of PowerShell.
Wow.
One line. He says, well, what were you doing? He says, well, I was doing this distributed WMI query, and then I was converting inventory information against a large set of servers. He says, and I was producing an HTML report. And PowerShell has get WMI that you can hand a large set of servers, and it gets all that information, and then you can pipe it to convert to HTML. And the guy says to me, this is great, the guy says, your HTML sucks.
Oh.
He says, but so did mine, and yours has only cost me a line of code, so it was a good deal. But we've made our HTML better in version 2.
Good.
We made it so that you can make it better. Yeah.
Yeah. And so to kind of, you know, go kind of, you know, you mentioned, like, you know, a lot of things where you can pipe to generate HTML and so on. So can we go a little bit more into the kind of pipes? So,
Yeah.
for example, you know, you can also do kind of, and you mentioned this way in the beginning, link. So you can do also kind of link-like things there, right? Where you can filter things as well and aggregate and so on. So can you
Yes, we used
drill
to-
down a little bit on like the descriptive power of the kind of, you know,
Yep.
of the pipes?
So basically you have, I'll put it into kind of 3 categories. So there's the kind of domain-specific stuff, the stuff that you as SQL or you as Exchange, that you and only you could write. Mailbox commands, table commands, etc. And so those, you're going to have your verbs, and we try and standardize the verbs so that everybody does the same things, that you learn it, etc. So that's one set of stuff. And we ship a few of those, kind of utility ones, but by and large you're going to get those from the community.
Okay.
And we're getting some great uptake on that. But then there's the what we used to call know-nothing commandlets, which is to say, I'll work with any object. I don't care, I don't know anything about it. So like filtering, you know, where.
Yeah.
And our where, you know, originally we tried to have where be as good as SQL, and we failed at that, so we had to be better. Originally we tried to be SQL, we did this, you know, blah blah blah, and it's a subset of the language, and then we looked at it and it was wrong, and it's like, this is never going to work, and it was taking way too long. So we had to be better, and by better what we did was instead, now what we do is we say where, we take the pipeline object and we assign it to a variable, $underbar, and then we run a lambda, and that lambda can be anything. And if the lambda evaluates to true, we pass the object on, and if it evaluates to false, we don't. So that lambda can be a simple expression, a complex sequence, or a 50-page script where you call your lifeline. Should I pass it on? Should I not?
Yeah.
You can do anything, and it'll go on. So that's my joke. It's better than SQL. It's far richer than
Yeah,
SQL.
well, but in that sense, it's very similar to link, right? Where in the where you also pass a lambda that's kind of, you know, in the end returns true or false. And
Exactly.
Yeah.
Yeah. So there's a bunch of a bunch of object commandlets: where, sorting, measuring, things like that. And then there's a set of utility functions. Hey, I have these objects and I'd like to convert them to HTML. I'd like to export it as CSV. I'd like to export it to XML. I'd like to format it. I'd like to format it as a list, as a table, as a wide, as a custom. I'd like to output it to a printer, output it to the screen, output it to a file, output it to a graph. So what we try and do is, by and large, your experience is going to be dominated by the first set of categories I mentioned, right? Because in my view, it's all about you think something, you type it, and you get it. And if you think, oh, I'd like to, add a mailbox, and there's an add mailbox command, you type it and you get it. But if that team didn't do add mailbox, then you're going to have to go look at some COM interface, some WMI glop, or some .NET Gorp, and you're like, oh my God. And my point is that there are people who will do that, but not many out of 10. 10 people look at that and say, thanks, I'll go buy a beer or something. I'm just not going to do that. So you want those set of commandlets. So my real task is to figure out and incent how to get all those feature teams, not just within Microsoft, but in the industry, to produce those.
Yes, yeah.
And my answer is, one, these .NET commandlets are tiny. They're tiny, 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 tiny. You don't write the parser, you don't write your filtering, you don't write your sorting, you don't write your formatting. They're tiny, tiny, tiny bits of code. And then when you emit your object, I produce a ton of these commandlets, these utility things that just provide a ton of value to your stuff. And that's really paid off. We had one team, I guess, can I talk about them? Well, I won't say, but I've been trying to get those guys for years. You got to do this, you got to do this, and they're like, yeah, talk to the hand, we're busy, blah blah blah. It's like, no, come on, it's important. And then at some point they peeled off an engineer, and he wrote some, and they sent me the mail. And this guy has this mail, he's like, look what you can do, and look what you can do, and look what you can do. And it's like breathless. And there's this big long list of all the things they could do, formatting and sorting and this and that and differencing. And then at the end he says, and here's the best thing, here's the code that it took to do it. And it's this little piece of code, and it enabled all these scenarios. And I looked at that and said, that's the first toke on the crack pipe, baby. These guys are hooked.
Yes.
And indeed, every team that's gone through it has had the same experience. Boy, this is a good value proposition. This is a good deal, and the customers love it. And the thing that we're now seeing, which is I'm so excited about, because now the business guys get it, is it not just is a great deal, great technology deal, small amount of code, huge amount of benefit, but it provides agility in the marketplace. So the virtual machine manager guys, they did this, and at their ship party, they were kind enough to invite me, and the leader said, oh, and our number one function is PowerShell. I was like, wow, I'm a fan of PowerShell, but I wouldn't have guessed that was your number one feature. And so afterwards I asked him, because he did this in front of a big group, I said, well, why did you say that? And he said, well, we always have to cut functions in order to ship the functions we do ship with the highest quality. He says, and then you spend the next 2 years trying to explain to people, no, we're not idiots, we know you need that, just hang in there for 2 years, and we'll deliver that to you. He says, and now, because everything's PowerShell enabled, we're able to say, yeah, here's how you do it, and here's a script and you can do it. And so that was one thought. And anyway, so they did that to great effect, and they were just beating the VMware like a gong. And the VMware guys looked at this, because the VMware had a scripting interface Perl-based, and they'd have one of these like, here's how you do it in VMware, and here's how you do it in Virtual Machine Manager. Well, they had a few of those, and the VMware guys said, hey, we'll have some of that. And they went and implemented, basically copying the commands that these guys did. So that's great, customers benefit, and so now they're parity. And then I just did, like 4 weeks ago, I saw some blog about how apparently we had some feature that they didn't, or they only had in their highest SKU, and some guy's like, no, don't go buy that product, here's a 100-line script and we can do it too. And so the point is that now they figured out that the scriptability and productive.
So you empower also users to kind of extend things
exactly
by making it easy.
See, that was a joke in the old management days, right? So management products. One of the jokes was told about a competitor.
Don't use the competitor's name.
There you go.
Have to edit it.
It was from a different company. But anyway, they'd say, their salespeople would say, hey, does your product do this? And the salespeople would say, yes, you can do this with our product. And at some point it's a joke, but another point it's like, no, that's the point. We provide you an infrastructure where you can do anything. And in reality, this product that already does that. It's called the C compiler. That you can do anything you want. So it's really a function of, well, how much effort do you have to put in?
Yes, but the bar is much higher.
Yeah, how much effort do you have to put in? And with PowerShell, the answer is pretty low. So yeah, we're just having a blast.
Yeah, that's nice. I'm just kind of drilling down again because something popped up in my head when you were kind of explaining the kind of, this whole phasing where you have your source and then in the end you kind of create, print it as HTML or do something. So now it kind of assumes that there's data flowing between each stage. But what if you have a command that kind of, say in C# terms returns void? So then there's no kind of real output. So how do you then still kind of glue them together? What is the kind of, does every commandlet have to produce output, or how do you do that?
No, but the way I like to say it is, so we often talk about, the difference between PowerShell and Unix. So Unix is pipelines of text, and PowerShell is pipelines of objects.
Yes.
Pipelines of objects is more powerful because you don't have to do text parsing. In reality, that's not true, right? In reality, Unix is not pipelines of text. Unix is pipelines of whatever. And here's the key point. It's the what you emit defines the ecosystem of your composition engine. So it's absolutely the case that in Unix, I can emit XML, okay? But if I emit XML, I can't pipe it to anybody because nobody can do anything interesting to it, right? So it's what you emit defines your ecosystem. And again, Unix, you can emit XML, you can emit ASN.1, etc. And there's just nobody to talk to it. So in reality, it's a self-tuned mechanism around one data stream, text stream, even though it could be anything. So it's the same thing. You can emit anything, you can emit nothing. And if you emit nothing, the question is, what's the ecosystem of people you can interestingly pipeline to? And the answer is, that's probably the null set.
Yeah, I understand it, but suppose that you have something that kind of, in C# terms returns nothing, it just has an effect. So what is the kind of recommended pattern then that it would return? Does it return itself, or,
so sometimes what we'll do is we'll say that sometimes it makes sense, the command itself makes sense not to emit anything, and fine, just do that. You type it at the command and it just does what it does and returns nothing. But then sometimes it makes sense to say, well, it's actually within a composition.
Exactly.
And so what we do there is we recommend that in the cases where you return nothing, that often what you'll have is a minus pass-through. If you're going to accept input from the pipeline, you have a minus pass-through, and that'll emit what was passed to you.
Okay.
Yeah.
Because you sometimes, even though you don't produce anything, you still want to sequence the actions. So you still want to kind of,
Absolutely.
pipe them in a certain order, but there's no kind of natural thing to kind of return.
Yep. Yeah, so we spent a lot of time trying to figure that stuff out. What are the set of guidelines that the Greeks had this idea of technos, technology, what you can do, and telos, what you should do. What are the activities that should happen? And a lot of times in Microsoft, we screw things up by focusing on the technos, what can be done, and not enough on the telos, telling people what they should do. Because indeed, when we spend a lot of time on that. Because if I go and say, hey, these commandlets, you can do anything, then it's just going to be just another incomprehensible sea of crap, right? And so what we do is we say, no, don't use the word kill, use the word stop. No, don't use the word terminate, use the word stop. And people are like, well, terminate, that's more precise. It's like, my friend, shut up. Use the word stop. Oh, kill is historical. People have been trained 30 years to use the word kill. It's like, no, the word stop. And then we try and be accommodating, but that's the key is to when to be a butthead, right? And you don't want to be an arbitrary butthead, but you want to be a butthead for your customers. If people have all these random words for the concept of stop, then the customer has to learn all these things, right? And so what we do is we say, no, use that standard term stop, and then if you have these other issues, just produce an alias, but support the standard. And so we have a lot of that. Hey, here are the things that if people just do anything lead to disharmony, and here are the things that if they do it, my customers are going to learn things once, and then they'll be able to guess and be right.
And do you have a tool like FXCOP or something like that kind of helps you to kind of check whether you follow your guidelines or?
Yeah, it's called the community.
Okay,
so right now there's no technology, but what I've been trying to do is to work with the community to get them to scream and complain and encourage you to do that, right? So at the end of the day, here's what I tell you. I only have so much power in this stuff. I mean, I go to the teams and I say, you got to do it this way, and they're doing some reasonably well. But outside the world, I don't have a lot of engagements with external vendors, right? They don't come to me saying, I'm thinking of using this word, would you please review things? So it's really up to the community to self-police. You know, if you see something that's not according to the standard and you don't scream and yell and make a big deal, then, you know, next year you're going to see 2 of them, and the year after that you're going to see 20, and then you're going to have a sea of crap, and I can't really help you there. So,
so that's a broken window theory. You don't let the windows be broken, but
yeah, exactly. Yeah. You know, you get what you settle for. So you should set. You know, we're trying to be very, very consistent. Again, back to that model of I learned something once. We view the admin's time as being sacrosanct, right? They don't have time to learn a whole bunch of stuff, but when they do learn it, the bet we make with them, or the deal we make with them, is learn it, and then we use it over and over and over and over and over and over and over again. So it's a good deal.
Yeah.
Interesting.
And is there so maybe the last question? We're kind of, you know, it's very interesting, but we're already kind of over an hour. Wow, that's like went fast. But is there some kind of, you know, marketplace or kind of, you know, where if you want to kind of, you know, get commandlets, from the community, is there a place where you can go and where you kind of, you know, aggregate all of them?
Yeah, there's a couple that are being formed. Great place to go is PowerShellCommunity.org. Script Center has one, etc. What I'm trying to do is to work with the community to define a standardized web service so that to these repositories, and then we'll ship a set of commandlets to be able to search for them and download them.
Great.
Yeah.
Okay. Great. Well, thanks a lot, and this was really interesting. I'm really kind of, you know, want to kind of get my hands kind of, you know, dirty doing some PowerShell hacking.
Great.
Yeah, it's really nice.
Thanks.